the shark bite, which ones did we have trouble with? Want to go over? Want to see? Had questions about anything like that?
Number
2 and 4. 2 and 4. Any others? So we can do 2 and 4. 2 should take you back to when we were doing literal equations, solving for a variable when there's a bunch of other variables. So for W, the easiest way to do this would be get rid of the 2L, subtract it to the other side. So we have P minus 2L equals 2W, and then divide everything by 2. So you can leave it like that, P minus 2L all over 2 equals W. Or if you wanted to simplify it, you'd have to divide it separately. So P over 2 minus L equals W. Either of those was fine. Questions on that one? For perimeter, we are adding up all the sides. It's a rectangle, so the sides are going to be the same as what's given. So you do one of two things. Add up everything you have, or take what you were given, the 2y and the 3y minus 5, and multiply those by 2. This would be 4y plus 6y minus 10, and then combine your literals. So if I knew what y was, I could actually find the perimeter, but I don't, so that's it. Questions on that? Before we start this new unit, let's talk a little bit. So make sure you can hear me. If you have both headphones in, take one out. The end of this quarter is in January. We just took this test, end of October. I should not see you retaking Unit 2B in January. You all have the time and opportunity to come get your retake work done and come before or after school to get your retake done way before then. So I should not see you all in my office hours the last week of the quarter struggling and rushing to get your retakes done. Does everyone understand what I just said? Okay. So that means starting today, if you said you want to retake, if you're available, come see me after school to start working on that stuff. Moving forward, additional practice if you need, so if you score below a 70, will just be Delta Math. That way we're not playing the I don't have this paper game. So additional practice is Delta Math. If you're not sure which ones, let me know and I can show you. Make sure your Khan Academies are done. That's still a requirement. And your test corrections have to be done and checked. And then once all that is done, upload and then you can retake. Questions on that? Everyone look at your calendar. Notice that our next and only flex day in November, as you guys voted, is the 22nd. So we are going to be working and learning until then. If you're not here that day, you miss your flex day. I know that's the last week before Thanksgiving break, so keep that in mind. Also notice that the plan is to test right before that. That way if you need to start working on test corrections, things like that, you have that day to do that. Questions on the schedule? Great. Look at the Khan Academy dates. They're also in Canvas. They're also in Khan Academy. Be aware of those dates. Put them in your phone calendar if you need to. That way you get those done beforehand. And then come see me with any of those if you're struggling with those, need help, just want me to double check before you submit it, or maybe you've tried it 3 times and keep getting a low score, any of those things. Right? Everyone look at your notes. So this unit, we are talking about systems. We'll talk about what that means here in 1 second. But everything else we've been talking about has been one equation, solving this one, getting one answer. Now we'll be solving 2 equations to still get one answer, but the answers could be different. So before we actually talk about how we do that, there are different ways to do that. We're going to talk about if we had solved it already, how would we know that this is the answer? So for these, if I got this as my answer for this, how would I know this works? How could I check to see this works? What do we think? Chris? Mm-hmm. So if you get something as an answer, and maybe you're not sure, is this the right answer? Put this back in for all of your variables. So this is x, this is y, put them in for everything. And see, does it work? Remember, these have to be true statements. If they're not true statements, it doesn't work. Because this is a system of equations, you have to check both. It could work for one and not the other. So if it works for one and not the other, then this is not your answer. But if it works for both, then it is your answer. So after putting that ordered pair into both equations, we see that both work. Because both work, we can say, yes, this is our solution. Double checking, as before, you should double check your work, make sure it works. Do we have any questions on that? Let's do one more. And then I'll let you try, and then we'll move on. Let's do 3. The format is different, but the process is the same. We do not need to change the order. We can put it directly in. 4 minus 4 times negative 2. Figure out, is that the same? The first one works. We still have to test out the second. The second one does not work, so this cannot be a solution. What questions do we have on that process? Getting the answer. After you have 3 written down, try 2 and 4, and I'll give you a couple minutes to do that. See or find that this did or did not work. It did not, correct. Anyone need to see that or why it didn't? For the fourth one, did that work or not work? You saying no? Did we all get that it did not work?
For 4?
For 4?
For me it works.
I was going to say it should have worked, so let's do that one. So this should be negative 10 plus 2, and that would give us negative 8. And then for the other one, negative 6 minus 2 should also give us this negative 8. So this one should have worked. Okay, so that's how you check yourself. If you've already graphed them, because one way to solve systems of equations is by graphing, you have to find where they intersect. So find that point and list it as an ordered pair. That would be your answer, your solution. So what is the solution for 6? Negative 1, negative 1. For 7, three, negative 1. And then for 8.
Negative 4, negative 2.
Negative 4, negative 2. So with your solution, make sure you're reading it x then y. Make sure you have your negatives. On the next page, actually, I feel like mine is a little out of order. This is the next page. At the top, it talks about the different types of solutions, but we're going to talk about that more in depth. So skip to this page. And then I'll have you fill in some stuff. So system of equations, the definition is 2 or more equations with the same variables. And here we're only going to do 2 equations. Algebra 2, I think you get to 3. I don't think you do more than that, but I don't know. And then the solution to a system graphically is the point xy where the 2 lines intersect or cross. Algebraically, it's the point xy that makes both equations true. So we just found both of those things algebraically and graphically. And then in the boxes below, I'm going to have you draw these diagrams. They don't have to be exact, just to the best of your ability. If you have 2 different colors, that might help, or like a pen and a pencil, that might help. Intersecting lines, they just have to cross, so 2 lines that cross, and in the middle, they have one solution, x, y. If they don't cross at all, so this is going back to last unit when we were talking about parallel perpendicular lines. If they don't cross at all, they are parallel lines. And because they never cross, they will never have a solution. Or we can have an instance where they lie on top of each other, so they end up being the exact same line. So technically they're intersecting at every single point along the line. So that means they have infinitely many solutions. So those 3 types of solutions come back into play here. Anyone still need this top part? Here are the steps on how we solve systems by graphing. 1, rewrite the equation in slope-intercept form if it's not already. 2, graph the 2 lines. 3, identify what the solution is. You will only have one of 3 answers. 1 solution where you have a point and you figure out what that point is. No solution because they don't cross, or infinitely many because they cross everywhere. Once we have all the instructions down, we'll actually put this in place. More pencils still writing, so I'll give you another 30 seconds. So let's put those steps into practice. Let's start with number 1. Do we have to change the format of these to slope-intercept form? No, they're already in slope-intercept form, so skip step 1. Graph them. This, I would say, it may be beneficial to you to graph them in 2 different colors. So if you want 2 different colors, I have colored pencils back here. You don't have to. I'm just saying it may help you see which one is which. I'm going to graph them in 2 different colors so that you know which one is which. Okay. Just like before, start at your y-intercept and then use your slope. So for this first one, we're going to start at -8. And then graph our slope. The slope is in front of x. It's invisible, but it's 1. It's positive, so we're going to go up and to the right as many times as possible. Build up your graph. If you need rulers, they're also in the colorful carts, along with the colored pencils. And then do the opposite from your y-intercept. Go down and to the left as many times as possible. Build up your graph. Connect all of your points and draw arrows at the end. And then do the other one. Yes. I don't think I have my iPad up, but. It'll be accepted by the time you get there. Okay. So we'll start at +1. Our slope is negative, so we can go up and to the left or down and to the right as many times as possible. Up to left 1, down to right 1, because all whole numbers are really over 1. With this, you have to be very careful. So when we did graphing, if your line was a little crooked, it was fine. But here we have to be exact, because if your line is off a little bit, it may not cross where it's supposed to. What is the solution of this? So as long as you graph these correctly, the solution should be easy to find. Do you have any questions about that? Let's do one on the back. Let's do 4. So 4, we do need to get these in slip intercept form. So if you don't remember how to do that, I would rewrite it so you have space. Move your x first by subtracting, or opposite of whatever it says. Flip them so it starts to look like y equals mx plus b. And then to get y by itself, we would do what? Divide everything by 2. So this is the same thing as negative 1/2 x plus 2. Look at the 2 equations we have. What do we notice about them? They're exactly the same. That means this is going to be the same line graphed on top of each other. So I can jump to the solution because I know this is going to be infinitely many, so you can put the infinity sign or IMS, either or. You do still have to graph it. And what I would say is graph one line and then draw extra arrows. So what I mean by that is this. So start at 2, go up 1 to the left 2 as many times as possible. And down 1 to the right 2 as many times as possible. And then after those arrows, draw like a second set of arrows. That would show me there are 2 lines graphed on top of each other. Or if you actually want to graph it twice, you could with 2 different colors. Or maybe draw one in pencil and highlight the other one. Or there are different variations. But you do have to show me that there are 2, otherwise you don't get full credit. Questions on that one? Look through the rest of these problems on this page, on the next page, on the rest of the pages. Find any problems you want to see, go over, have questions about. Maybe you're not sure where to start, want to double check, anything like that. On which page? 5, and then if there are any others, we'll come back. So one of two things. Here we have just a y equals. So our Hoybux is coming back. It's really not going away for a while. And then we also have an equation we have to solve. So we would need to subtract x on both sides. And divide everything by 3. So y equals -1 over 3x minus 5 is that other equation. Does not matter which one you graph first, they just both need to be graphed. So let's say I graph this one first. Start at -5. And then my slope is negative. Go up 1, left 3 as many times as possible. And down 1, right 3 as many times as possible. That would be one of your equations or one of your graphs. And then the other one, since this is a y equals, it needs to be a horizontal line at -7. This one is -5. I'm going to draw a point on my y-axis and then draw a horizontal line through that point. So what would my solution be? I'm going to show you two things. One is how you can check yourself in the calculator without doing it algebraically. And then the other is if you're at home, how you can check yourself using desmos. I'm going to go back to the front of this. And I'm going to put number 2 in my calculator. So do this with me. In your calculator, you're going to go into y equals at the top. If there's anything in there, clear it out. And we're going to put in both of those equations. Fraction is alpha y equals. Make sure you're using the negative button, not the minus. Y equals at the top. If there's anything in there, clear it out. Alpha y equals gives you your fraction. You can press this button for x. And then make sure you're using the negative sign at the bottom. 2. From the front, from this page. Everyone have this in y equals? We're going to double check because unless you reset your calculator, sometimes the window gets messed up. Go into window and just make sure this says -10, 10, -10, 10. If it doesn't, change it. Just delete it and type in -10, 10, -10, 10. In xmin, xmax, ymin, ymax. If those are already good, then you don't have to do anything. And then hit graph. So mine is in color so I can see it more clearly. You could count, but the calculator screen is so small, my eyesight is not the greatest sometimes, so I miscount. So instead of counting, you can make the calculator do the work for you. So we're going to go into second trace. And what do you think we're looking for? Intersect. So 5. And then it'll say first curve. That just means your first line. It should fall on one of the lines. If it does, hit enter. And then it'll say second curve, same thing. It should fall on the other line. If it does, hit enter. We don't want to guess. We want the calculator to figure that out. So hit enter again. And it'll tell us exactly what that intersection is. So -2e. Now, if you use this process to get me the solution, you still have to do the graphs. Questions about how we use the calculator to check for solutions? Dylan? Here, alpha 1 equals, and then that first one. Now we're going to pick a different one and do this in Desmos. So if you have this app on your phone, you can pull it up. Yes.
Is there going to be like a pattern of steps on it?
Not this time, because it's not calculator based, because you have to do it by hand. I'm going to put 7 from this page into Desmos. Missed what page I was talking about. This page, I'm doing number 7. What's nice about Desmos is I don't have to change anything. I don't have to solve anything. I can put it in exactly as is. So this will be nice when you're doing this practice at home and you're not sure and you want to double check. So I'm going to put these in exactly as is. 3x minus 5y equals -35. And then 2x plus y equals -6. It will show me my two graphs. If I click on the point at where they intersect, it'll tell me that intersection point. So definitely use Desmos when you're at home practicing, as you should be at home practicing when you're not here. Questions about Desmos or the calculator yet?
Are we allowed to use Desmos on a test?
No. That'd be too easy. Alright. Any other problems we want to see, go over, have questions about before I let you practice? For practice purposes, you have the rest of the problems in the notes. You can practice any of those. You have 2 Khan Academies for this that are due next Friday. One on graphing and finding the solution, and one on strictly finding the solution. So for that one, I would definitely say put them into Desmos and see what the solutions are. I also, if you want, have a graphing scavenger hunt around the room. So if you want that, you can come to me and I can get you something for that. But use this time actively, be actively practicing. Let me know.